Hello students, in the third semester of electrical engineering, we are going to study one subject, electrical power generation. This is the core subject and it is very important subject as far as electrical engineering is concerned. Now what is the motive behind adding this subject in the curriculum of diploma electrical engineers that we are going to discuss first. Electrical power plays a significant role in the development of industries and agriculture. With growing demand of electric power and diminishing of the fossil fuel, it has become important to generate power more efficiently. This course therefore deals in detail about generation of electric power using thermal, hydro, nuclear fuel, diesel and gas. This type of power plants need highly skilled technicians who are capable of operating various control equipment to supply uninterrupted power. This course attempts to develop the basic cognitive skills required to take appropriate decision to maintain the various generating and auxiliary equipment of the power plant and also aid for further studies in transmission, distribution, utilization and protection of power system for smooth and steady operation. What are the course outcome expected? So after completion of this curriculum, you should be able to maintain the optimized working of thermal power plant. You should be able to maintain the optimized working of large and micro hydro power plant. You should be able to maintain the optimized working of solar and biomass based power plant. You should be able to maintain the optimized working of wind power plant. And you should be able to select the adequate mix of power generation based on economics of operation. Now this is very important because we are generating the electricity by using various power plants such as thermal power plant, hydropower plant, nuclear power plant, solar and wind also. The per unit cost of generating the electricity with different power plant is different. So we need to properly select the mix of power generation. Now why we are going to focus more on the electrical energy? There are certain reasons. First one is it is convenient. So we can easily convert electrical energy into any other form of energy, such as electrical energy can be easily converted into light energy. Electrical energy is easily converted into heat energy. Electrical energy is easily converted into mechanical energy. Electrical energy is easily converted into chemical energy. So conversion is simple. That's why I'm going to prefer the electrical energy. Second, you can easily control the electricity. Take the example of fan. If I want to change the speed of the fan, what are you going to do? I will simply go to the regulator and change the position of regulator. The speed of the fan will vary. So control of electrical energy is easy. It is clean as compared to other sources of energy. Take the example of heater. When you are going to use the electrical heater, it will use for increasing the temperature of water. It does not form any ash or does not produce any gases. So it is clean. It is cheap. The cost of generating, cost of electricity is comparatively less as compared to using other sources of energy. Next one is the high transmission efficiency. Electricity can be transported over the distance of thousands of kilometers. Okay, and its efficiency is very good. So you can easily transport and the cost of transmission is comparatively less as compared to transporting the other form of energy. Now in the curriculum of electric power generation, this curriculum is divided into 5 units. In the first unit, you are going to focus on thermal power plant. In the second unit, we are going to discuss about the large and micro hydro power plant. In the third unit, we are going to discuss about the solar and biomass based power plant. In the fourth unit, we are going to discuss about the wind power plant. And the fifth unit, we are going to discuss about the economics of power generation and interconnected power system. Now starting with the first unit. The first unit deals with the thermal power plant. The thermal power plants are basically classified into 3 types: coal-based power plant, diesel electric power plant and nuclear power plants. So first we are going to discuss about the coal-based thermal power plant. In the thermal power plant, heat energy is converted into electrical energy. So in thermal power station, simply involves conversion of heat of coal combustion into electrical energy. The thermal power plant arrangement is basically divided into certain stages. What are those stages? First stage is coal and ash handling arrangement. Second is the steam generating plant. Third one is the steam turbine. And fourth one is the alternator. Fifth one is the water feed water system. And sixth one is the cooling arrangement. Now, these systems are just shown in the layout. So in the layout, you can just discuss over here. See over here the coal and ash handling plant. Then the boiler system. Here the water is converted into the steam. Then we have certain things over here. So here your steam is going to be superheated, then it goes to the turbine, then turbine will rotate with the help of steam, then turbine is coupled to the alternator. The alternator will convert mechanical energy into electrical energy, and this electrical energy is transported. Now when you are going to burn the coal, at that time it also produces certain gases. These gases will flow through these stages. Now these gases have certain heat. We can extract the heat in the superheater, then economizer, then air preheater, and then it will release into the atmosphere through chimney at certain height. Then we have this condenser system. This is the cooling system. We are going to discuss the cooling tower. So all these parts we are going to discuss in detail. Now first part is what? Coal handling plant. The coal is transported to the power station by road or rail and is stored in the coal storage plant. From the coal storage plant, the coal is delivered to the coal handling plant where it is pulverized. What is meant by pulverization? We are going to crush the cores into small pieces, or you are going to just convert into the powder form, so that the coal thermal efficiency of the coal will be increases. It can properly burn. In order to increase the rapid combustion without using large quantity of excess air, so pulverized coal is fed to the boiler by belt conveyor. So you can see, observe over here, these are the conveyors through which I can just transport the pulverized coal to the boiler. The coal is burned into the boiler and the ash is produced after the complete combustion of the coal, and this ash is removed by the ash handling plant. Then the next part is steam generating plant. In the steam generating plant, the steam generating plant consists of boiler for the production of steam and other auxiliary equipment for utilization of the flue gases. So what is boiler? A boiler is a device in which the heat of combustion of the coal in the boiler is utilized to convert water into steam at high temperature and pressure. The few gases from the boiler makes their journey through superheater, economizer, air preheater, and finally exhausted to the atmosphere through chimney. So typically there are two types of boiler: water tube boiler and fire tube boiler, that we are going to discuss later. Then next stage of your steam generating plant is what? This superheater, economizer, and air preheater. What is a superheater? The steam produced in the boiler is wet and is passed through the superheater where it is dried and superheated. That is, the steam temperature increase above that of the boiling point of water by the few gases on their way to chimney. Superheating avoids too much condensation in the last stage of turbine, which would cause blade corrosion. The superheated steam from the superheater is fed to the steam turbine through the main valve. Then economizer. The economizer is the economizer is essentially a feed water heater and derives heat from the few gases for this purpose. The feed water is fed to the economizer before supplying to the boiler. The economizer extracts the part of heat of the few gases to increase the feed water temperature. In that last stage of this one is the air preheater. An air preheater increases the temperature of the air supplied for the boiler. The economizer is essentially a feed water heater and derives heat from few gases for this purpose. The feed water is fed to the economizer before supplying it to the boiler. The economizer extracts the part of heat of the few gases to increase the temperature of feed water. What is air preheater? Air preheater increases the temperature of the air supplied for coal burning by deriving the heat from flue gases. Air is drawn from the atmosphere by a forced draft fan and is passed through the air preheater before supplying to the boiler furnace. Next is the steam turbine. The dry and superheated steam from the superheater is fed to the steam turbine through the main valve. The heat energy of the steam, when passing over the blades of the turbine, is converted into mechanical energy. After giving heat energy to the turbine, the steam is exhausted to the condenser, which condense the exhaust steam by means of the cold water circulation. So here the steam energy, heat energy is converted into the mechanical energy, movement of the turbine blades. Then alternator. The steam turbine is coupled to the alternator. The alternator converts mechanical energy of turbine into electrical energy. The electrical output of the turbine is derived to the bus bar through transformer, circuit breaker and isolator. Turbo generator. These are the generators which drives the steam turbine. The generators are run at very high speed of nearly 1500 rpm and above. Feed water. The condensed water from the condenser is used as a feed water for the boiler. Some water may be lost in the cycle, which is made up from extra sources such as river, lake. The feed water on its way to the boiler is heated by the water heater and economizer to increase the thermal efficiency. Then cooling arrangement. In order to improve the efficiency of the plant, the steam exhausted from the turbine is condensed by means of condenser. The water is drawn from the natural source of supply such as river, canal or lake and is circulated through the condenser. The circulating water takes up the heat of exhaust steam and itself become hot. The hot water coming out from the condenser is discharged into the river. Cooling tower. In case of unavailability of the water from the source throughout the year, the cooling towers are used. During the scarcity of the water in the river, hot water from the condenser is passed in the cooling towers where it is cooled. The cold water from the cooling tower is reused in the condenser. Ash handling plant. As coal is burned in the boiler and ash produced after the complete combustion of the coal, ash is removed in the ash handling plant and then is delivered to the ash storage plant for the disposal. The removal of the ash from the boiler furnace is necessary for proper burning of the coal. Typically, a 100 megawatt power station at 50% of the load factor may burn about 20,000 tons of coals per month, and the ash produced may be in tons of 10% to 15% of coal fire, that is 2 to 3,000 tons. So this is how your thermal power plant will work. Now in the thermal power plant, the coal will come, then it goes to the boiler where the coal is burned along with the hot air which is coming from the air preheater. After burning of the coal, steam is produced. The economizer, through the economizer water is given, so steam is produced. Okay, this steam is passes through the superheater. The heat of the few gases increases the temperature of the steam further, and that increases up to 500 degrees centigrade or more than that. Then that superheated steam goes to the turbine where the turbine blades get rotated. The turbine is coupled to the alternator. Alternator also rotate, and alternator will convert the mechanical energy into electrical energy. Typically we are getting 11 kV over here. This is going to be increased with the help of step-up transformer, that may be 132 kV or 220 kV, and then it is connected to the bus bars. Then the exhaust steam from the turbine is given to the condenser where this steam is going to be condensed. Okay, and to make up, we are going to take water from river or certain lakes. If you don't have the sufficient water, then we are going to use the cooling tower arrangement where the hot steam is going to be cool over here, and that is converted into the water again, and that is given to the economizer or to the boiler through feed water system. So we have the feed water pump over here, and through the economizer. Why you are giving the using the economizer over here? The economizer will increase the temperature of the water. So initially, if this temperature is 30 degrees centigrade, water temperature, through the economizer, when it passes through the economizer, here you are getting the water whose temperature is nearly 40 to 50 degrees centigrade. So the energy required for increasing the temperature in the boiler is comparatively less over here. Then that few gases again pass through the air preheater. So the atmospheric air may contain moisture. So these few gases are still hot. So this a forced draft fan is used to push the atmospheric air into the boiler, and that pass through the air preheater. So what the few gases will do over here? The few gases will extract the moisture content or increase the temperature of the air, and if is there any moisture content, that is going to be removed, and you are getting the hot over here. So that will again increases the thermal efficiency. So air preheater, economizer and superheater are basically used to increase the thermal efficiency of the boiler system. So this is a basic description of the thermal power plant. In the next lecture we are going to discuss